I also want to thank the journal for giving me the opportunity to give a talk in this Frontiers Forum. Um, and I think it's an interesting communication way inside the community for inviting some expert or scholars to present the relevant topics that covered well in our journal. So my topic is about transforming construction using intelligent systems. As you know, there's a lot of words recently, whatever you call it. Actually, before this terminology appeared, the back to about 25 years ago when I was a master's student in University of Washington, and then after that was in the PhD at Purdue University. And at that moment, we didn't have a words like smart construction. We don't even use smart or intelligent. I would say from the perspective of construction engineering management, the earliest is probably computing and civil engineering. And then later on, similar words like automation, construction, advanced engineering, informatics, informatics in civil engineering, that sort of things. And so that pretty much covered the different aspects of what we call smart construction at the moment. And also smart construction is basically a concept where a lot of scholars in the world can keep contributing to further defining it based on their own areas. So when I studied the PhD, we have my PhD supervisor at that moment basically along with the other young scholars in Middle West of the United States, like Purdue, Penn State, Georgia Tech, Virginia Tech, and a few universities like that. So they basically have what we call a young generation between like 30 to 40. They do a lot of work in computing and civil engineering. So that's probably the fundamental age for where we're forming at the smart construction for the moment, for now. And then after my PhD, I went to Australia. I started as a university senior lecturer and then UNSW senior lecturer and then Curtin for almost for 13, 14 years. So when I actually landed in Australia, there's nobody in construction doing anything related to the serious IT application in construction. So I basically have nobody to rely on. So I took whatever I learned from the United States research community, and I very luckily that I came across the largest energy company in Australia, Woodside. So I became the Woodside chair for oil and gas and construction project management. So I basically have the resources to also combine with the ARC, Australian Research Council, I have the enough resources to apply what I learned in US community into Australian industry, not just in oil and gas, but also in building and infrastructure and also in minerals as well. So anyway, so that's my brief story of how I developed my career. And then about 5 years ago, I started to work with China. Well, actually 10 years ago. I started work with China a lot and also other parts of the world. For example, we started the first Australasian Joint Research Center on BIM with Huazhong University of Science and Technology back about a decade ago. And then we developed that into many communities and trained a lot of students after that. So basically the good innovational concepts we developed in Australia, and we actually have the opportunity to apply it in some of the Asian countries. So because they have a lessons from our test beds, and then we get a lot of research outcomes out of it as well. Okay, so if we look at the smart construction, basically, I was classified that into three phases. Okay, the first phase would be more like, so here is the analogy. Okay, so similarity. So if we compare with the human brain, all right, because I personally believe that the construction site is an experimental test bed. And also it is can be regarded as intelligent being, not that like us so advanced, but it can have some sort of level of intelligence. Okay, so if it is an intelligent entity, then it will have some similarity with the human brain. Okay, so for example, like uh, uh, just like a human brain, the construction have the brain cells. Okay, so how, as an engineering information perception system based on the next generation computer vision, how can we use those technology to collect, right, the information we need on the site in a real-time manner, and then they function as a human brain cells. And then once we have the brain cells, we can start to analyze the memory, and then, that sort of interaction, that sort of things. So through data storage and interaction, driven by the domain knowledge, this second stage can facilitate the storage of information in various formats and enable data sharing. So this actually is the interaction between the brain cells. And then the third phase would be simulating the interconnectivity among various brain regions. Okay, so this can be realized by the Internet of Things on the site, and then to connect materials, labor, instruments, equipment, and also a few other things all together, and to create a comprehensive digital management of the key engineering components, so that in the future, the ultimate vision for this will be a totally manless construction site. Okay, so you don't have man in it. Actually, it's not just free the labor, but also in the future can also free the engineers as well. So as we have the next generation AI getting to place, a lot of future designer engineers work or roles will be easily replaced, so that we actually free the engineer's brain. So if you look at, as I mentioned earlier, that engineering, or we call it engineering or project, basically, it has, just like human being, it has a brain, it has limbs, it has organs. Okay, so brain is equivalent to a smart system on the site. A limbs is equivalent to the smart equipment on the site. Like when you actually do earth moving, right? You need an excavator. You need a few other equipment. So those are the we call actuators that will reshape the physical environments by following the orders that created into the by following orders created in the virtual space. And also engineering projects have organs as well. So this is equivalent to the smart materials. So we have different types of materials. They function differently. So they just like human organs. So they can have a one-to-one mapping, and to organically constitute an engineering brain, as I call it. So every engineering project should have a brain to think autonomously or semi-autonomously. So there's a few well, as at the beginning of my lecture, I talked about the where the smart construction comes from. There's a few journals that can be representative for the timelines in this area. So it's basically started very could be very traced back very early in early 1980s, 1970s, very initial adoption of information tools. Um, um, well, there's a few papers published by Journal of Construction Engineering Management. And then in 1990s, there's an obvious a booming application of computing technologies. So that's where the other journal of computing and civil engineering actually is also ASCE journal, took off from that that period. And in the new century, there's when the concept building information modeling and integrated management comes in place. And there's a journal like Automation Construction, or AEI, further developed as well. And then after 10 years, we have journals of IT in Construction, Journal of Building Performance Simulation, more focusing on digitalisation, intelligent technologies. And recently, there are a few other journals, like the Journal of Building Engineering and Robotics, Computer Aid Integrated in Manufacturing as well. So this gives you a very brief overview of how the journals actually appear and take off along the timeline of the evolution of smart construction. There's a few societies that you probably be very familiar with, directly relevant to smart construction. For example, like ASCE, they have a few work committees that directly related to BIM and also computing and civil engineering. There's another society called International Society for Computing, Civil and Building Engineering. This is a very old-chased society. Can be, I think it's started in 1980s. I am currently the country representative and board of directors for that society. They have a biannual conference. The third one is called IARC, International Association for Automation, Robotics, and Construction. This one I was elected as the vice president for industry last year. This is also I think it was started in Houston back in 1990 or 80s. It seems to be very active promoter on smart construction. I mean, when we talk about smart construction, it's really broad, okay? And to be more specific, some scholars focus on construction robots, some focus on IoT, some focus on BIM, now AI, and so on. So this is also a good community to be involved. There's another society I want to bring it up, and for your awareness, just in case that you're not aware of that before. As I mentioned before, I was working. I worked in Australia for almost 20 years, where about 10 years of time I was running an industry alliance of smart technologies called Katrina. And then starting from last year, we actually rebranded and restructured Katrina into a new society. This society was officially started from last year, but actually has a foundation of 10 years of industry alliance. So I would say this year would be the 11th year of it. So SCP stands for Smart Construction and Production. Here, the production is not manufacturing. The production here means the production or whatever manufacturing that is directly related to construction. Okay, for example, like prefab steel, prefab housing, prefab concrete. So the production or manufacturing directly related to construction. Okay, so here we're not talking about like car manufacturing called car production, or plane or any other like chips or so this is totally related to construction industry. It started actually by three founding presidents, myself and Professor Vijay Singh is a fellow of United States National Academy of Engineering. currently in Texas A&M. Professor Conrad Bergmeister he's actually a fellow of the is a fellow of many academies. Okay, fellow of Leopoldina, the National Academy of Science in Germany, and also National Academy uh, of uh, and also a National Academy of Engineering as well, and also the European Academy of Science and Arts. So it's very the both of them are very leading uh, iconic image in the areas. And the Professor Vijay Singh is more focused on smart waters, which is good from from the different disciplines. We don't want the society only focusing on construction engineering management. And Professor Bergmeister is focusing on tunnel construction. So, as I mentioned before, SCP is started as Katrina Industry Alliance for almost 10 years. And we have a very broad audiences, both from academic and industry sectors, including energy, mining, infrastructure, and building construction. And we are dedicated to advancing cutting-edge research, technological application, industry standardization in smart construction manufacturing. So here's a QR code. Okay, if you use WeChat, you can use your phone to scan and subscribe. So something more about we have a website, and if you click the governance, we have a governance board of about 10 people. They're all fellows of either Academy of Engineering or Academy of Sciences, from most of them from developed countries. And also I have a long list of about 30 international scientific committee members from 5 continents, many countries. And also we have the task group with the different themes. Okay, so we have task group of GIS, task group of 3D printing, task group of BIM. So with different themes. We also give awards. If you check out the tab of awards, we have 9 categories of awards where we give annually. Most likely, we give them physically in our annual conference, which I'm going to introduce in the next slide. We also have a few encouraged journals, including our journal. So the annual conference, we do a conference every year. Last year was in Perth. This year, again, we'll be in Perth again. In early August, the conference chair is Dr. Junbo Song. This is last year information. Okay, and Junbo is will be happy to host everybody in Perth in that time. So back to engineering brain. Okay, back to engineering brain. We look at the human brain here. They have a different sections. They function differently. I don't want to go too very deep, okay, into this this PPT, because I know that most of us are not like a cognitive science background. So we basically can use different current smart technologies to map them along with the different segments of the human brain, okay, to let them do the work. For example, so on the left, let's imagine this is a smart construction site, okay, with all the required technical components. On the right-hand side will be human brain. So let's pick, for example, like occipital. The occipital lobe in orange, basically in our brain, is responsible for vision. So it's responsible for processing the information that we see from our eyes. And this is exactly equivalent to what? To in our smart construction scenario, it will be equivalent to the computer vision based intelligent monitoring system. For example, on a site, you could have like surveillance cameras. And those cameras are your eyes, and they collect the information to interweave together to create a picture of what actually happened in the site. So this is like the eyes of the brain. So, and then if we look at the parietal lobe, this one in red is equivalent to, is actually handles the non-vision data, for example, like touch, smell, or other sensory inputs. Okay, it correlates in smart construction side would be sensor-based intelligent monitoring system. For example, like the smoke alarm. Okay, smoke alarm. Smoke is not what you see. It's not visual information. Smoke alarm or displacement sensors, stress sensors, strain sensors, and also maybe sounds, noise, that sort of things. So they equivalent to parietal lobe. And if we look at the frontal gyrus, it actually further divided into superior, middle, and inferior. Superior is responsible for brain analysis. Okay, so brain analysis and equivalent to, like, on the side we have a like AI based decision making system. So that's unit is for analysis. So this is exactly equivalence. And the middle one is more responsible for processing language, communication, display. Okay. So on the site, you will have, right, either a tablet or your iPhone or display screen to actually display for communication. Another one, inferior frontal. Inferior basically responsible for motor functions. So once our brain analyze, right, and then we analyze, we make a decision, and then we have to control. We got to control our bodies, right? For example, if I run too long, I want to stop, then I stop my legs. So that's more like an interface between your brain order and your physical environment. So, and in this case, the inferior gyrus is on the site perspective would be more equivalent to like equipment on the site, like a crane, tower crane, excavator, labors, equipment, tools. Either could be a small tools like screwdriver, and also a few other whatever you can use to reshape the physical environment. The last one would be temporal lobe in the light green color, is responsible for memory. So build information modeling, Bing is exactly a good database for memory. So, well, there could be now a more intelligent data storage system like cloud. So if we go back to this slide, as you can see, we mapping the different smart technologies onto different, for example, like the occipital lobe, in charge of vision analysis. It can equivalent to like cameras, or sometimes the UAV carried point clouds laser scanner. The laser scanner or photogrammetry, they can scan the environment for you. And also parietal lobe can processing the non-vision data, okay, like the smoke sensors or pressure sensors, RFID sensing, and also even GPS as well. For the interest of time, I'm not going to go through each of them, but this is just an indicative image to help you to understand. So the smart construction, how it will actually develop. It's three stages as well, starting from the smart paperless construction, and then smart automated construction, and then autonomous construction. From the names, you can already capture what I mean here. So eventually, we want an autonomous, totally no man, not just no labor, but also no designers and engineers as well. So in the phase one, we are pretty much in the phase one, completed well. It's smart paperless construction. For example, the Bing collaborative platform, everything we do in the BIM, no paper. I know a lot of company design firms, they start to switch to paperless. On-site digital documentation, the same thing, real-time construction data recording, right? If on-site and you do inspections, and then normally you have a pen and paper to write a report. Now you just use your tablet, and it will automatically process the data and create the spreadsheets for you. So this advantage of that is increase the work efficiency, minimize errors, human errors, and reduce materials waste and so on. And smart construction monitoring is also widely used as well. Okay, and you have drone and robot inspection. This robot inspection drone and a few other early warning systems. The advantage of that is real-time monitoring, accurate data, and so on. So these are very good support. Okay. These are the brain cells I mentioned before in the stage one. Okay, you need these cells. You need the data to be seamlessly collected and integrated. So that's the basic. So once you have that, and then they provide the support for comprehensive data support for engineering brain. So this will leads to the second phase. Okay, so first phase we did a few case studies, and for example, like this one, we have a bridge. And over the bridge, we have the cameras installed. We use some algorithm. We can minimize the layout, the numbers of cameras required for a specific length of a bridge. So once you got that, and we can quickly create a digital twin model of the entire bridge, including the vehicles and pedestrians on the bridge as well. So through this, you actually have all the brain cells, okay, for you. So the phase two will be more like based on the AI, large models and deep reinforced learning. We try to minimize the schedule, cost, and resources to have a more automatic generation of it. So recent years, AI large model is very popular, and what does it mean to our domain? Deep reinforcement learning is also very important methodology to combine deep learning and reinforced learning, and so on. So how we actually leverage those models and new generation of AI algorithm, and then to use them, right, to generate the schedule, cost, and resources plan for us. So this leads to AI-driven construction plan, multi-dimension plan comparison, and also a few other initiatives. So the third stage will be autonomous. Okay, autonomous construction. Autonomous construction also have 3 stages or sub-stages. Okay, start with the human. It cannot be like without human at the first instance. It has to rely on human. So human robot phase get started, and then robot human phase, and then robot phase. Okay, so what we mean by human robot phase is robots can rely on human operation and command. Okay, so human can still have their experience and are responsible for decision making and control, and robots basically to follow the order and implement the mechanical tasks. Okay, and then the second stage, robot human phase will be robots autonomously perform certain construction tasks through engineering brain and provide real-time feedback to human for decision making. So this is a different, okay, the difference between the first phase and second phase. First phase, human initialize. Second phase, robot initialize. Okay, but still needs to get the feedback from the human in closing the loop. And the ideal future scenario would be robot phase. Okay, so robot work with the robot. Right now we are worker work with the worker, a worker with worker, a worker work with the equipment. In the future will be robot work with robot, and you can treat any smart equipment as a robot as well. So robots fully rely on intelligence system based on engineering brain to autonomously coordinate and execute smart construction tasks. So that's exactly what we see as a future engineering brain will play a role. And it will facilitate the collaboration among robots and also enable real-time optimization of task schedules. It can predict the faults and monitor the quality and progress management. So an example, this actually has been partially applied in the car manufacturing industry. So an example of that would be multiple robots can work together to complete a task such as smart construction assembly and component installation without human intervention. So as I said before, with the autonomous stage, autonomous construction will not just free the laborer's hands by enabling automation. It's more about how we actually free the brain of designers and engineers on the side, or even managers on the side, so that robot and robot can work autonomous together with each other to reshape the physical environment. So AI has been very popular recently. It's just give you a very brief recapture of where AI came from and how it develops. It actually started from 1950s or 40s. Okay, it started very simple concept, and then it has different substream. The robotics people come and pick up the idea and they develop that through robotics, heuristics, neural network, image, expert system, knowledge reasoning. They're all different substreams for AI, and sometimes some stream develop much quicker than the other stream. Some are developing quicker in the early stage, but slower in the later stage, and so on. So anyway, so some of the substream they actually form into one stream in the future. And somehow like this. So a lot of people ask me what the smart construction or engineering brain will follow in the future. I would say it will pretty much follow the evolution of AI. Okay, so because if the AI is basically to study the human, how the human actually thinks, and then try to mimic human thinks with machines. And if, as I said before, if we treat construction as an intelligent entity, then it has an intelligence itself. Then how we actually treat it as intelligent, how we actually learn from it, how we actually apply the human intelligence into the construction intelligence, and so on. So I would say construction intelligence will pretty much follow the same development cycle. Okay. And and also the physical world and the cyber world are also very important. We talk a lot about the digital twins. When we say smart, it's pretty much smart in the virtual space, like we use AI in a computing unit, so that's virtual. But actually, you're living in this physical world. You do construction in the physical world. So this is a trade-off. Not just as a twin, where you have a mapping between physical and the virtual, but it's more like a trade-off. When you make more decisions in the physical world or using human experience in construction, and then you actually diminish the effects that from the cyber world, like AI algorithm, and also the other way around. So in the future, I think we should, in construction, we should actually use whatever the cyber world can give to you, or whatever technology can give it to you, rather than rely on the previous manner. So finally, I want to do a little bit promotion for the conference of IPC Innovative Production and Construction Conference this year. It's the 11th. You can scan the code for registration or more information. It will happen starting from the 4th of August in Perth, Australia. So conference themes will be very broad, covering transportation to construction, and we also have water, geotechnical materials, structures, scholars to attend, smart city development, building materials, a few other things. So, okay, so this is my presentation. I think we are pretty much on track in terms of timing, about 30 minutes. So maybe we can have time for a few questions from audiences.
Thank you, Professor Wang. That's very truly inspirational speech. I'm pretty sure many of our audience will, like me, are truly inspired by your, you know, further explore this very interesting field of research. So there is one question in the chat box, but probably it's my privilege as a chair if I could ask you a couple of questions, if you don't mind, Professor Wang.
Yeah.
I guess but this is absolutely the future of the not just construction but probably AEC in general that presents the future direction of the research and also practices. What's your view, as you are the leading scientist in this particular field? What's your advice for, and I'm pretty sure you will have a lot of followers. So what would be your advice to our many future generations of researchers, in terms of the future research agenda? Well, I mean, you've apparently have opened a field that is very, very inspirational, but what would you advise of the junior researchers to start with?
Yes. Thank you, Professor Zuo, for the question. I think that's a very, very interesting and also very important question. I would say we are currently in a very special age. Okay, we are in a very special age where we have so many new smart technologies come into our vision, horizon, and almost one or two every month. And there's so many smart technologies, but nobody actually pay much attention to it for their daily job beyond their daily entertainment. So we can have a lot of entertainment with the smart technology, but for our daily job, we never think about it. So I would say the current generation or the current and the next generation of AI, particularly as an example, will be very revolutionary, and we cannot avoid it. Okay, and it's happened so fast. It will change every aspect of our life. Whatever, whether or not you like it, it will change our lifestyle. So I would say for the young generations, if you are really interested in research, but also not just for community research community, but also for the engineering. If you work for a company, you also need to think about what these technologies which is available now can do for a daily job, because everything will move very quickly to smart. Okay, and if you miss the boat, and you miss the boat, and you'll be there'll be a lot of losses associated with it. So I would say we think about, and also I think for smart construction, the entry, we'll call it entry threshold, is not very high. Okay, because it's not a traditional research areas, not like some areas in structural, very traditional, and then you have to learn maybe the last 50 years of literature before you actually find a sensible research topic. So the smart construction is very new. It's very interdisciplinary. Okay, it's basically a thinking method of how you actually use the new ways to solve old problems, or use new ways to solve new problems. The it's because technology is always available, so the threshold is not very high. But it's good. You need to think about the good mapping. Okay, why you choose technology A to solve problem B? Okay, that's the hypothesis, which is not very easy to get to. But I would say for all the construction, construction scholars, I would say this is unavoidable for future. And whether or not you do research in sustainability or you do research in materials, I mean, AI can always help you, to speed up the your impact or the solutions that you can get.
Thank you, Professor Wang. I think I think you've addressed many of the future, researchers' doubt, and I guess they all will be very, very inspired to continue researching this particular engineering area. I just have one small question before I give it to the audience. I think your description of the engineering brand is quite interesting, like using the brand name and the organs to map out the functions of different areas in the on site, etc. A few years ago, I was in Xiamen visiting the subway construction, and we were taken through all the BIM model and digital twin models they've been using, and it was pretty well. I think they are truly inspired by the technologies and has been used in the practices to manage the whole project. Now, one challenge they mentioned is about the data storage. They were talking about 500 gig of data being generated in 1 month. So I guess that could be related to the engineering brand and like stomach, and that you have have a lot of data being generated, but you have to store it and then digest it for indexing for the future usage. Do you have any suggestion what need to be in place? What kind of system need to be in place to make sure the
Yeah,
data, can be used, can be reused in the future in an easy manner?
right. Yes. Yes. This is the well, data overloading or data storage problem. So on the one hand, we need data. So we always want much more data than what we need for our current jobs.
Mm,
Because we're not sure what our current job, what our what the data we will need for exactly our jobs. Okay. So I think when we actually get into more and more understanding what smart construction is, or understanding what the technologies can do for your daily job, and then you will find out, okay, I only need maybe 10% of the data um, um, that I usually collect to finish my job. So I would say the first initial collection of data is important, but the updating of the data can be more smart, or can be smarter, right? So I would say more can be put in as a dynamic way. So based on your job, and then it will create a need, and the need will actually define what the data will be, and then it will drive the update of your data. So that can somehow release the storage requirements. And how to do that? There's a few AI methods that can somehow. I have another lecture where we actually have a pipeline. So basically, like a pipeline of, rather than you collect all the data you can collect and then feed it into the problem you will solve, you actually need to find what your problem is and define it and build the models around it. And then you use your model to define what the minimal data set you will need. And then that data will be collected by your cameras or whatever sensors on the site. So it's actually the other way around. Okay, so it's a need driven rather than want driven. Okay, want driven basically means I put all whatever sensors I can on the site within my budget, and then I collect whatever data I can collect. So that would be one day would be an overloading, but this is more like a need driven. Okay, need driven will have a prerequisite, which is we need to understand what the problem is, exactly the problem, and also build the model around it.
mm. Thanks, Professor Wang. I think that the Subway Corporation should have been in contact with you soon to deal with this issue. But it's thank you for pointing that out. I think that needs driven is very spot on. That's exactly what we should do rather than just connecting whatever data and then figure out what data we need. So thank you very much, Professor Wang. Now I'll give the stage back to the audience. So this one question we received in the chat box from Kenza. So Kenza, are you happy to have your mic on to directly ask Professor Wang the question, or you want me to read the question for you? Brenda.
Thank you so
Sorry,
much,
Kenza.
Professor. Oh, yeah, thank you so much for your introduction. Okay, thank you so much again, Professor Wang. It was really an informative presentation that you gave, and I'm truly inspired, as already Professor Zhao was telling. You are inspiring the future generation of the young and junior scholars. So, in my field, I'm interested on how to integrate smart technologies into construction and into architecture in general. And now I'm specialized into the AI. So I would like to know from your perspective, what are the limitations of integrating AI into construction? Because the construction field is very complex and it is a vast field, especially for nowadays. So this is the first question about the limitations of using AI. And the second question, if it will be possible to know also how we can focus on integrating the AI in a very productive way in the construction field so we can get good results in order to enhance the field into efficiency and also for the productivity. Thank you so much.
Yeah, thank you, Kenza, for the question. Well, I think these are two very challenging questions because I'm actually doing daily research trying to tackle some of them. Um, Construction is different from manufacturing. Okay, manufacturing is much easier to apply AI, whatever smart technology on because um, it's very structured assembly line in manufacturing, but in construction, very fragmented. And also depending on which country we're talking about, and also what kind of project and what level of labors and equipment and construction companies. So they're very complicated. Okay, I would say what we can target on is the common problems, uh, and also very critical problems in construction, and that problem is also very representative. And we use that problem, and then we think about how smart technology can be used, can be tackled. You can only get the conclusion after you actually experiment it on. Um, so how to find the problems? I mean, talking to the engineers would be the easiest way. So they can give you tons of problems to solve. So once you have a problem you target on, and then you ask yourself what smart technologies you think of. And you can, if you go to internet, you can find over 100 different smart technologies. I would say sometimes you need to rely on your intuitions. Okay, you probably learn or read a lot of like smart manufacturing papers or newspapers, so you find out maybe XYZ algorithm has been applied to solve a assembly line problem, and then that assembly line problem will be similar in nature with some of your construction tasks. So a logic assumption could be made then, right? Say, okay, this XYZ technology can solve that problem. Why this cannot be solved my problem in a similar way in construction? Then you actually much what we call it, the short list, right? The technologies that we will be focusing on. So I would say that using that way would be probably most effective way to 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 um to get into smart construction research. The second question you mentioned, sorry, can you repeat the second question briefly?
Yeah, it was about the limitations of using AI in the construction field.
Oh, limitation. That's the first question. Limitations are, there's a lot of limitations. There's so many. Budget, limited resources, you know, Construction workers, they probably don't want to use it. Site managers don't want to use it. Yeah, there's a lot of, obstacles. Um, a lot of times it's not the technology not working. It's more like the way you apply technology is not working. Okay. So I always emphasize that we are, as construction researchers, we're not trying to invent um, a new smart technology. We are inventing a new way of applying existing smart technologies to solve existing construction problems. Okay. So that's also a principle we need to use to train our construction management graduates towards smart thinking. Oh, yes, that's the word. Smart thinking is more important than smart technologies.
Thank you
Did
so
that make
much.
sense?
Yes, thank you so much.
Yeah. You're welcome.
Well, thank you, Professor Wang, and also Kenza for your question. Just wondering, well, we still have the stage open for more questions. We still have a couple minutes before we close the session at 4 o'clock Beijing time.
Yeah.
If you do have any question, please just have your mic on and you can raise the question directly to Professor Wang. Well, if not, Professor Wang, just a very, very quick question. How, I mean, apparently there will be a lot of data to be generated. Do you have any suggestion for our, young researchers about making early decision in terms of the data quality? So what kind of consideration need to be taken, or be conscious about, whatever the data they've been received? Do you have any suggestion?
It's complicated because it really depends on the problem you're trying to solve. Um, there's some standard tools that can cleansing your data based on some previous learnings, but it's not very effective. I would say sometimes we're not just improving the data, but also improving the cleansing way. When you improve the cleansing way, it will somehow tailor-made a new cleansing way for this particular problem. Okay. So this way, you started with a standard method, but then you actually evolve into a much more advanced customization.
Mhm. That's very good advice. Thank you, Professor Wang. Well, if there's no more question, I'd like to draw the end of this session. And thank you very much again for Professor Wang, your truly inspirational speech about this fantastic topic. And apparently there's a lot of work can be done. And hopefully we can see a lot of, young researchers will follow your suggestion to conduct more research. So let's put our hands together. So thank you, Professor Wang, for your truly inspirational speech. Thank you. And just one more small announcement. The next Frontier Forum will be 3 p.m. again, 19th of May. The speaker is the Professor Matt Santamolis from University of New South Wales, Australia. So the topic of his speech is addressing the impact of urban overheating using advanced heat mitigation technologies. Okay, so on this, I'd like to draw the conclusion of this session. So thank you for the speaker, Professor Wang, and also thank you for the audience being very interactive, very actively engaged in the interaction with Professor Wang. So thank you, everyone. Have a nice day today, and also the future in advance. Thank you. All the best. Bye.
Thank you. Bye-bye.
Thank you.